Hi, welcome to video 8.7c part 2, the last two indeterminate forms, 0 to the power of 0 and infinity to the power of 0.
Enough if I plug in 4, I get 3 times 0 is 0, 4 minus 4 is 0, so I get 0 over 0 to the 0. So I let y equal that function, 3 times x minus 4 to the x minus 4. Take the ln of each side, which will allow me to bring the power in front. Take the limit of each side. And now I have, I'm trying to figure out, take the limit of each side. That's all I did from here to here. And now what happens is if I substitute now, I get 4 minus 4 is 0. And then I have the ln of 3 times negative infinity, which is negative infinity minus 12 is negative infinity. So what happens is, as you have the ln of infinity, which I don't know why I circled this, but the ln, the ln of negative infinity. That's not making sense. I'm sorry. It's the limit as x approaches 4. 3 times 4 is 12. 12 minus 12 is 0. And that's why it said 4 from the right, by the way. The reason that right was from there, because as x approaches 4 from the right, this is going to approach 0 from the right. And if you take the graph of y equals ln, and you approach 0 from the right, you're approaching negative infinity. So I do get a 0 times negative infinity. So I'm going to use the reciprocal. I'll leave the ln on the top. Instead of times x minus 4, I'll divide by 1 over x minus 4. There's nothing to simplify. I'll substitute. Again, I get the ln of 0 from the right, which is negative infinity. On the bottom, if I plug in 4, I get 1 over 0, which is a constant, a non-zero over 0. Top is positive. The bottom is approaching 0 through positives because this is approaching 4 from the right. So I get negative infinity over infinity, which allows me to use L'Hopital's. The derivative of the numerator is 1 over 3x minus 12 times the derivative of 3. Over on the side here, x minus 4 to the negative 1. The derivative is negative x minus 4 to the negative 2, so I'm just rewriting that as negative 1 over x minus 4 squared. Now remember, what you want to do now is you want to simplify. And again, I cannot emphasize enough how important it is that you simplify. Okay, so it's just a complex fraction. You take the top, and I factored out the 3 and multiply by the reciprocal of the bottom. The 3's cancel, the x minus 4's cancel, and you're left basically with, as if I plug in 4, I have 0 over negative 1, which of course is 0. Remember, the answer is not 0. We're now going to get rid of the ln on the other side. It becomes e to the 0, which is 1. So again, be careful of that. Here's number 80. If I plug in 1, I get 0 to the ln of 1 from the right. If you approach 1 from the right on the graph of y equals ln x, you're approaching 0. So it is that one of the 3 indeterminate forms. I let y equal the function, take the ln of each side, which will allow me to pull the exponent out in front. Take the limit of each side as x approaches 1 from the right. If I plug that in, the ln as x approaches 1 from the right, we saw is 0. And the ln of 0, and if you approach 1 from the right, this is approaching 0 from the right, again, will be that negative infinity. So I do end up with 0 times negative infinity, so I do the reciprocal, leave the ln on top. Instead of times ln x, I divide by 1 over ln x. And so now I get infinity over infinity, because the ln of 0 from the right is, negative infinity. And the ln of 1 from the right is 0. That's going to be 1 over 0 through positives. So a positive over 0 through positive will be positive infinity. That gives me the right to use L'Hopital's. The derivative of the numerator is 1 over x minus 1. This, of course, is just ln x to the negative 1, so the derivative of that is negative 1 ln x to the negative 2 times the derivative of ln x. And then, of course, I'm just kind of polishing it up a little bit. I'm moving that ln of x to the negative 2 to be over ln of x to the 2. And then what am I doing? Once again, from here to here, I am simplifying. Okay, so this whole simplifying thing, sorry I'm writing with the pen here, but if you don't do this, it's going to cause a lot of problems. Oh my goodness me. Okay, simplify. Okay, so it's a complex fraction. I'll bring this up to the top, and I end up with this expression right here. Now, if I plug in 1, the limit as x approaches 1 from the right is 0. Squared is 0, so I get a 0 on top, times 1. And then on the bottom I have 1 minus 1, which is 0. I get to use L'Hopital's again. Aren't we lucky? So, the derivative of the top, unfortunately, is a product rule. So you're going to have the first factor times the derivative of the second factor, which will be 2 times ln x to the 1 times the derivative of ln x, plus the second factor, which is ln x squared, times the derivative of negative x, which is negative 1, and then the derivative of the bottom, remember we're using L'Hopital's, is 1. Well, very nicely, these x's cancel, and now when I plug in my 1, I have negative 1 times, the limit as x approaches 1 from the right is 0, 2 times 0 is 0, so I have negative 1, 2 times 0, plus the ln of x as x approaches 1 from the right is 0, 0 squared, times negative 1. And of course, all of that worked to get 0, but remember the answer is not 0, the answer is e to the 0, because I have to get rid of it. Whoops. I have to get rid of this ln over here by doing e to the power on the right side. Okay? So, quick summary of all the indeterminate forms that we've learned in this whole section. Of course, there was the 0 over 0 or infinity over infinity, where we get to use L'Hopital's. There was infinity minus infinity, which will usually happen with fractions, so you combine. And the other one we saw was 0 times infinity or 0 times negative infinity, where you use the reciprocal, which will give you one of these two, which will allow you to use L'Hopital's. And of course, the last three that we saw, where you let y equal the function, take the ln of each side, take the limit of each side. You're going to bring that exponent right in front because it's an ln. And then you'll evaluate this down to remember, don't forget at the end the answer.